Hi everyone. So in our last two videos, we talked about different ways of combining functions. So first we talked about combining functions with addition, subtraction, multiplication, and division. And then we talked about combining functions with a new operation called composition. So in the last two videos, I would say that the focus was kind of algebraic, right? We were focusing on, especially in the first video, how do you actually go through the algebra of like adding together different fractional functions, things like that. And then same thing with the composition, right? It was a lot about how do you go about plugging this expression into this function, how does the algebra actually pan out? And so this video is going to focus more on kind of like the concept of combining functions. And the way that we're going to be focusing on that concept is by looking at graphs of functions and how to combine functions from their graphs. So before we get to the graphs, I want to do a warm-up question. And so this is not going to be like directly related to graphs of combined functions, but I think in order to understand the next thing we're going to do, I need to make sure that you understand this. So this is stuff that we talked about in the last couple of videos. So I'm going to give you two different functions. So let's say that we have one function f of x, which is equal to the square root of 2x plus 5, and another function g of x, which is equal to x squared plus 1. And so what we want to find here is we want to find f plus g, not of x, but just of 10. And similarly, f times g of 10, g composed with f of 10, and the other order, so f of g of 10. So we talked a little bit about examples like this in the past couple of videos, and we said that there were kind of two different ways to do it. And so I would encourage you to think about what are those two different ways of answering these types of questions. So yeah, pause the video, try these yourself, and then come back and we'll talk about how to do it. So I'm actually going to color code these just so that I think it will help us kind of talk about them a little bit. Okay, so let's start with the first one. So f plus g of 10. So there's two ways to do this. One way is that you could first write down the formula for f plus g of x, right? You could come up with the formula like we did for most of that first video about combining functions, right? We were just writing down these formulas for different combined functions. And you could totally do that. So you could combine the two functions and then plug 10 into the new function, right? That would work. But I think what's kind of a simpler approach, and what will help us to do this with graphs in a little bit, is to understand that rather than combining the function first and then plugging in the number, you can also split this up, right? You can say this is equal to f of 10 plus g of 10. And I don't really want you to think of this as like we're using the distributive property. This is just the definition of adding together functions, right? We know that in general, f plus g of x is equal to f of x plus g of x. And so we're just using that same idea, but putting the number 10 in for x. Okay, so now all we have to do is figure out what is f of 10 and what is g of 10 and just add those two numbers up. We don't have to ever actually really combine the functions. So f of 10 is going to be equal to the square root of 2 times 10 plus 5. And then g of 10 is going to be equal to 10 squared plus 1. And so it looks like we get, for the first part, we get the square root of 25, so that's going to be equal to 5. And then for the second part, we have 100 plus 1, so that's 101. And so for our final answer, we would get 106. Okay, so next up we have f times g of 10. So again, there's two ways to do this. You could, if you wanted to, make the formula for f times g of x. And once you have that new formula, you can just plug 10 into it. But because we're only evaluating this at a single point, because the question isn't really asking you to find the formula, it's just asking you to find this one specific answer, it's a little easier, I think, just to go directly and plug in the number into each of them. Okay, so what is f of 10? Well, we actually already found that above, right? That was equal to 5. And what was f of 10? Well, we found above that that was equal to 101. And so to find f times g of 10, we just have to multiply 5 times 101, and that is going to equal 505. Okay, so next up we have the composition problems, which I think are a little bit trickier. So let's start with g composed with f of x. And I'll go down here. I was going to go up there so I could reference the functions, but we know what the functions are. Okay, so first we have g of f of x. So the first step is we want to rewrite this as similar to g of f of 10. So actually, let me say one thing before I jump into what I was about to say. So similarly to the earlier ones, you could do this by first finding a formula for g composed with f of x. That would work. And then once you have that brand new function, then you can plug 10 into that function. Alternatively, what you can do is kind of what we did above. So we can rewrite g composed with f as like this, basically g of f of 10. Right? That's really what this composition means. It means you're taking one function and plugging into the other one. And so we know what f of 10 is, right? We actually just found that right here, or earlier we found it. We found that f of 10 is equal to 5. And so g of f of 10, well, that's the same thing as g of 5. And so now how do we find what g of 5 is? Well, we have a function, g of x, right? G of x is equal to x squared plus 1. And so g of 5 is going to be equal to 5 squared plus 1. And that is going to be equal to 26. So it's really the same idea as we use for rewriting the formula. It's just that instead of, usually at this step, right, we would replace f of x with what f of x actually was and write it there. Similarly here, we're just replacing f of 10 with what f of 10 actually is. So let's do the other order here. So if we want to do f composed with g, f of g of x, of 10, so same idea, but this time the f is going to be on the outside, right? So this time we're doing f of g of 10. And so earlier we found what g of 10 was, right? So g of 10 was equal to 101. And so we can just replace g of 10 with the number 101 because that's what g of 10 is. And so now all we have to do is plug 101 into the function g of x. And so, f of x, my bad, right? Because now we're doing f of 101. And so what was the function f of x? Well, it's the square root of 2 times x plus 5. So we're just plugging the number 101 into that. So that's going to be equal to the square root of 2 times 101 plus 5. And so that is going to simplify to the square root of 207. So this square root can actually be reduced. It can be written as the square root of 9 times the square root of 23. And that ultimately simplifies to 3 times the square root of 23. Okay, so this is the idea that we're now going to use when composing functions by looking at their graphs. So I have pulled up here a couple of functions, f of x and g of x. And in this case, we do not have formulas for f of x and g of x. However, we'll see that even without formulas, we can still figure out what f plus g of different numbers is. And then same thing, we'll do a composition as well. So we're going to start by figuring out some values for f plus g. So we're going to do f plus g of 0. We're going to do f plus g of 1. We're going to do f plus g of 2. f plus g of 3, f plus g of 4, and f plus g of 5. And I know that probably looks like a lot, but these will go actually pretty quickly. Okay, so first one. So what was that kind of reasoning that we used in the last example? Well, we said that rather than write down a formula for f plus g of x, what we can do is we can say, well, f plus g of 0, that's the same thing as f of 0 plus g of 0. And so how can we figure out what f of 0 and g of 0 are? Well, we have a graph right here, right? These are our functions. We're not given formulas for our functions, but we're given a picture of the functions. And so from this picture, we can see that f of 0 is -1, right? Because the y value is -1. So we can rewrite this as -1 plus, and then g of 0, we can see from this picture, is equal to 3. And so we have -1 plus 3. And so that tells us that f plus g of 0 is equal to 2. So now that you've seen the first one, I would encourage you to pause the video and try these next few yourself. It's going to be the same idea. So next we have f of 1 plus g of 1. And so f of 1, we can see is equal to -2. And g of 1 is equal to 2. So we have -2 plus 2, and that is going to be equal to 0. And by the way, I know it seems like we're doing a lot of these. There's a reason for it. So what we're going to do is once we've calculated all of these, we're going to use them to actually sketch the graph of f plus g of x. Okay, so for 2, again, we have f of 2 plus g of 2. So if we look at our graph, we can see that f of 2 is going to be equal to -1, g of 2 is going to be equal to 1. So we have -1 plus 1. And so again, we get 0 for that value. Okay, so then we have f plus g of 3. So that's f of 3 plus g of 3. And so that's going to be looking now at what happens when x is equal to 3. So these actually have the same value when x is equal to 3. They're both equal to 2. So that means that we have 2 plus 2, which is 4. F plus g of 4. So that is going to be, we can look at our picture and see that f of 4 is going to be equal to 5, and g of 4 is going to be equal to 3. And so we have 5 plus 3, and so that gives us 8. Okay, last one. So f plus g of 5, that means we're doing f of 5 plus g of 5. And so that is going to be equal to, so we can see that f of 5 is equal to 6, g of 5 is equal to 0. And so we have 6 plus 0, and so that is going to be equal to 6. Okay. Cool, so we have all of this information about this new function f plus g of x, right? So the thing I want you to remember is that when you're doing this process of adding together functions, you truly get a new function. And it's a function just like any function. You can plug numbers into it, you can graph it, you can do everything you can do with any function. And so in this case, we don't have a formula, but we do have a bunch of information about this new function. Specifically, we have a bunch of information that we can actually interpret as points. So what do I mean by that? Well, think about, forget for a second about all of this stuff in the middle. Ignore that for a moment. And so what does this first line say? Well, it says f plus g of 0 is equal to 2. And so remember that f plus g, that's just the name of our new function. If you wanted to, you could even call it h. You could say h of 0 is equal to 2, right? F plus g is just, think of it as just a label. It's a name for this new function. And so what point, like what is going to be the point on our graph that corresponds to that? Well, we can see that the input is 0 and the output is 2. And so the point on our new graph is going to be the point 0, 2. And so this point here is a point on the graph of f plus g of x. And then similarly, we can see that when the input is 1, the output is 0. And so we have a point 1, 0. When the input is 2, the output is 0, so we have a point at 2, 0. When we have the input is 3, the output is 4, and so we have the point 3, 4. And finally, when the input is 4, or not finally, almost finally, when the input is 4, the output is 8, and so we have this point up here. And then finally, when the input is 5, the output is 6, so we have a point here. Okay, so let me uncross this out because this, this is important. It's how we got it. It's just that when you're actually graphing it, you don't really need to know that, right? You just have a series of inputs and outputs. And so now we can connect the dots, and we have to kind of guess a little bit about what it's going to look like. So, if, for example, so I would say the first part probably we can kind of figure out, right? It's probably going to be something like that. How do I know that it's not a straight line? Well, basically, if you think about, what could the equations be for these graphs? The equations for g of x, those would be linear. It would be a piecewise linear function, right? It has 3 pieces that are straight lines. But the graph of f of x is curved, so that can't be a linear function. And so when you add functions together and one of them is not linear, there's no way you can end up with a linear function. So that's how I know that there would be like a slight curve to it. Now, it's a little unclear what happens between 1 and 2. It doesn't really make sense, at least to me, that it would go like straight across like that. So let's come back to that point in a little bit. Let's just continue to fill the rest of it in. So, something like this, something kind of curved, and then it goes up, and then it comes back down. And you don't need to do a perfect job. I wouldn't expect you to know exactly what it looks like, but we can just kind of connect it in a way that looks like a believable graph. So how could we figure out what happens between 1 and 2? Well, we could actually plug in a number. It would be like a little bit less clear because it wouldn't be a whole number. But for example, we could do f plus g of 1.5 if we wanted to get an idea of what's going on there. And so that would be f of 1.5 plus g of 1.5. And we're going to have to estimate for this one, but it can at least give us an idea of like what's going on between those two values. So f of 1.5, and maybe I'll put an equals about because we can't tell exactly what's going on. But f of 1.5, it looks like that is about, I don't know, maybe negative 1.7 seems reasonable to me. So let's say negative 1.7. And then what would g of 1.5 be? Well, that one looks a little bit easier to guess. That looks to me like it's 1.5. And so we get as our approximate answer, okay, it looks like it's approximately negative 0.2. But the important thing is that it's negative, right? It lies below, the graph is going to go below the x-axis at this part. And the reason I can tell that for sure is that even though this point here was an estimation, we can definitely tell that it's lower than 1.5, right? 1.5 would be like here, and we have a point that's here. So it's definitely below 1.5, and so we're going to be subtracting more than what we have as our positive number, and so we're going to end up with it dipping below. So I'm just going to estimate something like that. So that is our new function f plus g of x, and we can even label it on our graph. Okay, so now we're going to do the same thing but with composition. So it's really going to be the same idea, just now working with plugging one function into another. So sorry, I thought that I had set this up, but I guess I forgot. Just going to erase out our new function. Okay. So for this function, we're going to do f composed with g of x. So similarly to what we did earlier, we're going to do f composed with g of 0, f composed with g of 1, f composed with g of 2, f composed with g of 3, f composed with g of 4, and f composed with g of 5. So I think this process is going to be a little trickier than the last one, and we'll see why. It's basically because you're kind of forced to look at different parts of the graph to figure out what the final output is going to be. Okay, so let's start by writing this down as we can rewrite f composed with g of x as f of g, or I should say f composed with g of 0 as f of g of 0. And so the first thing we need to figure out is what is g of 0? And so g of 0, we look at the graph of g of x and we can say, okay, g of 0 is equal to 3. And so we can rewrite this as f of 3. And then how do we figure out what f of 3 is? Well, now we need to go and look at when x is equal to 3, what is the output on the graph of f of x? And so we can see that f of 3 is equal to 2. And so our final answer here is 2. So like I said, I think this feels maybe a little more confusing because you're kind of jumping around on the graph. So I think the important thing is to take it step by step. Don't try to do too many things at once. Take it one step at a time. So again, our first step was just rewriting this as f of g of 0. Then we figured out what g of 0 was. You start on the inside, right? You start by figuring out what's going on with the inside function. We figured out g of 0 by looking at the graph. And then once we had g of 0 as a number, kind of like what we talked about earlier, you can like forget about this and forget about this for a second and just focus on this. What is f of 3? And to evaluate f of 3, you just look at the graph and you look at what is the y value when x is equal to 3. Okay, so let's keep going with this. And like I said on the last one, I would encourage you to pause the video and try these ones yourself now that you've seen how it goes. Okay, so next up we have f of g of 1. And so we want to look at the graph and figure out first what is g of 1. So g of 1 is equal to 2. So that means that this function is going to be f of 2. So again, we can now forget about all the other stuff and just focus on evaluating f of 2. So what is f of 2? Well, when x is equal to 2, y is equal to negative 1 on the function f of x. And so our answer is negative 1. Okay, so next up we have f of g of 2. So that is going to include evaluating g of 2 first. Okay, so to find g of 2, we go to an x value of 2 and look at our graph of g of x, and we see that g of 2 is 1. And so that means that we're doing f of 1. And so what is f of 1? Well, forgetting about everything else and just focusing on the graph of f of x, we see that when x is equal to 1, f of 1 is equal to negative 2. So next up we have f of g of 3. So that is going to involve first finding g of 3. So g of 3 is equal to 2. So we now have f of 2, and that one we already found above, right? So we found earlier that f of 2 was equal to negative 1, or you could just look at the graph again. But I think that's kind of interesting. So why is that happening? Why are we getting kind of the same thing happening here? It's because the function of g of x has repeated values, right? If we look at g of 1 and g of 3, they have the same output. G of 1 and g of 3 is both of those are equal to 2. And so that's why even though our original inputs were different, we ended up with the same input at the end of the day, like plugging it into f of x. Okay, so now we have f of g of 4. So that is going to be equal to f of, so g of 4, we look at when x is equal to 4, and we can see that g of 4 is equal to 3. So again, we get this repeating situation, right? Because basically the graph of g of x like zigzags up and down. And so we end up with f of 3, which we already saw was equal to 2. And then finally we have f of g of 5. So g of 5 is equal to, looking at our graph, it's equal to 0, right? G of 5 is equal to 0, and so we have f of 0 and so f of 0, according to our graph, is equal to -1, right here. F of 0 is -1. And so that is our last value. Okay, so what do we do with all this? Like, what is this, this information that we have? Well, basically, just like in the other example we did, we now have a series of inputs and outputs, right? So forgetting about all this for a second, just ignore kind of where we got the values from. We have this new function f composed with g, right? Just like f plus g, we can think of this as being a whole entire new function. It's like a function called h of x, but it just happens to be called f of g of x. And so just like with any other function, we have our inputs and we have our outputs. And so when we plot the points of this graph, we want to just plot the inputs as our x coordinates and the outputs as our y coordinates. So we have the point 0, 2. We have the point 1, -1. We have the point 2, -2. We have 3, -1. We have 4, 2. And finally, we have 5, -1. And so again, we don't know exactly what this graph looks like between the points, so I'm just going to kind of connect them in a way that looks reasonable. I think we can assume again that like the graph shouldn't be straight lines, right? Because one of the functions involved is not itself straight lines, it just doesn't really make sense that the new function would be straight lines or would be composed of straight lines. So there's one question I want to ask before we just look at one last thing. So notice that I chose to do this as f of g of x instead of g of f of x. So my question is, why wouldn't g of f of x have worked? Or kind of like, what's wrong with trying to find like if we tried to go through the same exact process of plugging in all these numbers, what would have kind of tripped us up when we tried to calculate g composed with f? So I'd encourage you to pause the video and try to figure out what's going on. Like, why did I choose to do it in this order? So it's basically just one part of the graph that wouldn't work. So let's say that we tried to calculate g composed with f of 5. So that would mean that now we have g on the outside, so we'd be doing g of f of 5. So what is f of 5? Well, according to the graph, f of 5 is equal to 6, right? That's the output when x is 5. And so we would have g of 6. Okay, so what's wrong with that? What's wrong with g of 6? Well, our function for g of x, its domain is only from 0 to 5, right? The graph just doesn't exist over here. And so there's no information about what happens when x is equal to 6. And so basically this would just not exist. And so it's undefined because the domain of g of x basically is only everything from 0 to 5. And you might think, well, that's okay, right? Because it looks like we were plugging in 5. But the problem is we plugged 5 into the original function, but really what that meant was that we were plugging 5 into f of x, and that part was okay. The issue was that once we plugged 5 into f of x, we got 6, and 6 fell outside of the domain. So this isn't something we're really going to delve into, but I just wanted to kind of point it out that there can be issues when you're composing functions. Basically, their domains need to line up. In order to compose functions, it needs to be the case that anything that can come out of the inside function has to be in the domain of the outside function. Otherwise, you'll get a situation like this, where you're trying to plug a number into something and you don't have a result. So one last thing I just want to quickly show you is that you can play around with this idea of adding, subtracting, multiplying, dividing, composing functions in Desmos. So if you give Desmos two functions, so I gave it f of x is equal to x minus 1 squared plus 2, so that's the parabola, the red graph. And then I also gave it g of x is equal to 1 over x, so that's this blue graph. That is a graph that we'll be talking about in a little bit in this class. And so once you have two functions defined, as long as you write them in function notation, it doesn't let you write f plus g of x. It doesn't accept that notation, but what you can do is write f of x plus g of x. And that will give you the function that you would get by adding these two together. And so this is kind of, it's consistent with what we did earlier. So like, for example, if we look at the blue graph has a point at 1, 1. The red graph has a point at 1, 2. And so if you add those two y coordinates together, you get 3. And so that's why there's a y coordinate of 3 on this green graph. And so you can kind of, if you go through and test out different points, you can start to understand like, why is this green graph shaped the way it is. So I also did f of x times g of x. And so that gives you this graph. And then I did f composed with g. So this one, g of x is on the inside. So we get this kind of interesting looking graph. And then finally, I have g composed with f gives us this less interesting looking graph. But yeah, I would encourage you to play around with this, try different functions, and try to combine them in different ways and see what kind of things come out. And like I said, I think it's really interesting to do that, and then also try to, like, once you have the combined graph, try to work backwards and understand why does that graph look the way it does. All right, so that is it for this video, and I will see you on the next video.